All right, today we're going to compare and contrast position time graphs and velocity time graphs. Here we have Toucan Sam perched in a tree. Toucan Sam likes to fly back and forth near his tree. We're going to plot Toucan Sam's position on this position time graph. So Toucan Sam took off in this direction. He flew all the way out to 30 meters in 1 second. So after 1 second, he went from 0 to 30 meters. Now he's going to sit there for a second. So he's going to stay there in that spot for 1 second. Then he's going to turn and fly this way and stop here, 20 meters from the tree. And that's after 3 seconds. So there's 2, 3, 4, 5, 6. Okay, so at 3 seconds, he was at 20 meters. Then, at second 4, he was at 15 meters. That's right there. Then he went this way and flew to 25 meters. At second number 5. And then he flew all the way back home. So back to 0 after 6 seconds. Okay, so we can see how his position changed over time. At 1 second, he was here. Then he stayed at 30 meters for another second. Then at time 3, he was at 20 meters. So the next second, he flew here. At time 4, he was at 15 meters. So he flew here. At time 5, 25 meters. And at time 6, he was all the way back to 0. Now let's take a closer look at this section of the time graph, of the position time graph, in between seconds 0 and second 1. The y-axis, we have meters. It's distance. We have distance. On the y-axis, we have distance. So that's rise, right? So we will go from 0 to 30 meters. And on time, we go from 0 to 1. And that gives us 30 meters in 1 second. So this is our change. Change in distance over change in time. So that is our slope. Rise over run is our change in distance divided by our change in time. And we already know from one of our previous lessons that this is velocity. Velocity is change in distance over change in time. And The triangle here, this is the Greek letter delta, that represents change. So delta d over delta t is change in distance divided by change in time. So what does this mean? 30 meters in 1 second, or 30 meters per second. That is the velocity of the toucan for the first second when he flies from 0 to 30 meters. So the slope of the line on a position time graph is equal to the velocity. So what was the velocity here when he sat there for 1 second? It was 0. There's no slope, so no velocity. What about from time 2 to time 3? From here to here, we go from 30 meters to 20 meters. So 20 minus 30 over 1 second is equal to negative 10 meters per second. So from time 2 to 3, the toucan was flying negative 10 meters per second. Because remember, in velocity, the sign matters. If you're flying backwards, you're going negative velocity. If you're flying forwards, you're going positive velocity. Remember, speed doesn't have a sign, but velocity does. I plotted the same motion on a velocity time graph. Now let's compare the two. Remember, the slope of the line on the position time graph is the velocity. So from 0 to 1 second, we moved 30 meters in the positive direction. So we went 30 meters in 1 second, or 30 meters per second. So between 0 and 1, we're moving at 30 meters per second. So notice all of my lines on the velocity time graph are either straight, they're either horizontal or vertical. What that tells you is that the velocity was constant because they're straight lines. So he didn't speed up to 30 miles an hour. As soon as he took off flying, he was going 30 miles an hour. This is kind of unrealistic, but we're going to start with simpler problems and move on to harder ones. So for now, we're dealing with constant velocity. He took off at a constant velocity of 30 meters per second, and then at 1 second, after 1 second, he stopped. Remember? He stopped moving. So he flew here and then stayed there for 1 second. So the position didn't change. From 1 second to 2 seconds, he remained at 30 meters. So there was no velocity at this point. So let's look at our velocity time graph. At 1 second, he was at 30 meters. Then from 1 to 2, he didn't go anywhere, so his velocity was 0. So we went from 30 meters per second to 0 meters per second. Now from 2 to 3, we went from 30 meters to 20 meters. So he flew from here to here. So he went backwards 10 meters in 1 second. So his velocity then was negative 10 meters per second. And then he flew from 20 meters to 15 meters in the next second. 20 to 15, that's minus 5. That's minus 5 meters per second. So now we're here. Then from 4 seconds to 5 seconds, we went from 15 back to 25. So we went from here to here. That's 10. The difference between 15 and 25 is 10 meters per second. And then finally, from 5 seconds to 6 seconds, he flew back to the tree. So that was 25 meters in the negative direction, from 25 to 0. So he was going negative 25 meters per second for this last second. You can see how the position time graphs and the velocity time graphs are related. The slope on the line of the position time graph is the velocity on the velocity time graph. But remember, velocity is equal to the change in distance over the change in time. We want to look at this particular section of the velocity time graph. Recall that the area of a square, or any rectangle, is just base times height. So let's call our base t and our height v. Remember, we can rearrange any equation, and if we rearrange this equation to solve for distance, you have change in distance is equal to velocity times change in time. Delta d equals v times delta t. So by this logic, base times height, if our base is t and our height is v, then our area should be the distance we covered. Now let's see if that's true. From 2 to 3 is just 1 second. So if this is 1 second, and our velocity, right here, we went -10. So our base is 1 second, and our height is -10 meters per second. 1 second times -10 meters per second is equal to -10 meters, because your seconds will cancel out. And if we look back at our position time graph, at this time, remember, we went from 30 meters to 20 meters. So we went -10 meters. So you see the area under the curve on a velocity time graph is the distance traveled. Well, I hope you're beginning to see that all of this that you've been doing is related. The distance, displacement, position time graphs, velocity time graphs, they're all related. And pretty soon, we're going to move into acceleration. But for now, we're dealing with constant velocity, so that's no acceleration. So we're just, here he's going 30 meters per second. Here he's going 0. Here he's going 10. He's not gaining speed or losing speed. We're moving at constant velocity. But always feel free to go back and rewatch the video if you didn't pick everything up. Thank you for watching.